Okay, everybody, this is Andy. I'm going to do the practical follow-up video with the correlation and predictions video that I just posted. So what we're going to do with this, we're going to start doing some of the math associated with that chapter and kind of show you what the plug and play and how to make it work. So as I said earlier, it's really best to really break it down into chunks. So what you can see here is the R formula, and I have it broken down to the numerator and denominator. I have this upper arrow, which helps me identify that's the numerator, and plus if you're ever in a class or a lecture setting that you're performing a test, it also helps the proctor to see what exactly you're working with or what you're following on. So here you can see the formula I already had set up. Right here, let me just put in, and then we got x squared, and then we got x squared, but we got parentheses on this sucker, and the same thing over here, we got n y squared and y squared outside the parentheses. All right. Now this is coming out of table 4.1, and it's a modified table that I created basically, or a created table that I modified. You can see I took out the chin-ups portion basically because it helps follow through with later in the chapter when you see the weight and pull-ups chart that's in the textbook. So let's work with this one for a little bit and just kind of pan over into and use this as our primary example. So here you can see that I've already, let me pull this back up, you can see that I've already broken it down into those sections like I suggested on the previous video. You have your columns, you got your x column, x squared column, y squared column, and you can let Excel do all the math for you. Now don't pay attention to the mean just yet, we'll get to that one later when we talk about the slope formula, slope intercept. So let's plug and play like I said. Right here, you can see I've already labeled each category where those numbers should play into. So let's run with this one for a moment. All right, I'm going to use this marker here just so we can identify what's being worked on, what's not being worked on. So 10 times 9,630. Again, we're following the PEMDAS or the orders of operations here. So we need to first analyze and make sure the formula is set up the right way. So first things first, we want to make sure that your parentheses are in the right area, because especially if you code it in a calculator and your parentheses are not in the right area, you're going to get a totally different answer and you're going to chase the rabbit down the wrong hole basically. So again, let's work this. Put parentheses here, put parentheses here, put parentheses here, and right here. So now, even if you throw this in like Excel, like I did, it makes it easier for Excel to kind of see what we're doing with. So as we know, when we're looking for ppm, we need to find a number that ranges from -1 to +1. Anything outside those numbers, there's an error in the math. So that's a good way to say if you got like a 1.1, or like I did earlier and I had an 18 point something, I knew there was something wrong with the way how I was bracketing and breaking down the formula, so I had to play around with it until I got it basically to get within those two numbers. So again, first things first, let's just read it from left to right and go with it now. So we got 10 times 9,630, so that's 96,300, right? Then make sure my math is done right. This one here, we got 1,520 times 65. That one was 98,800. Right, so that's 0. Okay, so now we've got a couple of numbers that we can work with for the numerator. Let's knock this bad boy out. So what do we got? We got a -2,500. Sit right there on the numerator. Now we got that out of the way, let's talk about the denominator. The denominator is a bit of a pain. So when you think of it, again, you got to look at the orders of operations, because one, you know, let me just write these out. We got that, we got E, we got M, we got D, we got A, and we got S. So basically this exponent can also be the square root. So always keep that in mind as well. As you can see, you want to take these in steps, you want to take these in chunks. Sometimes, like through Excel again, you could slap it all in there and it'll do what it's supposed to do. Basically, even if you miscode it somewhere, it'll give you a correction and say, hey, I think it's supposed to be like this. Do you accept? You hit OK, and then it fixes itself. So it's one of those scary situations where technology is actually smarter than most of us. So we need to keep this in the back of our head as we run through this equation, mainly because, like, even though this is the number 2, you don't really need to do that till the very end. So for this situation, let's put the square root down here as opposed to up here. And I know it's contrary to what's been taught in elementary school. So let's look at this. Let's break it down again. All right, so we got 2 sections. We got this first piece here, we got the second piece here. We got our x's, we got our y's. Let's get a couple of variables that we can work with and try to find that r value, that straight r value. So here we got 10 times 23,300 minus the x value, and you want to square it, so that's the 1520 squared. So this is going to be a pretty big number. I'm more than likely going to have to erase to make some more space because my board is small. So what we got now, we need to add a 0 to this because I wrote it down wrong. So it's 10 times 233,000, right? To recount what I just said. So 10 times that, we got 2,330,000. Got 2 little tick marks there. Minus, what is that? That's I got it written down on my note card because I'm not that smart. That's 2,003,000 or 310,400, and that gives us a number, right? So that number, if I could do my math off this. This one is 19,600. So yeah, 19,600. All right, that's our first step. That's our first point of interest here. So now we need to work on part B of the denominator. So let's bring these numbers down here, which would be, what was that, 10, is that 5,010 minus 65. Now this one's a little bit easier than the last one, so that's 4,225. And we got another number. I know that says solo. Got Star Wars in my head. It's 4,025. That's 785. 785. Right? We got that going for us. Now we got 2 numbers. So let's line these up. Right? We got our 19,600 minus the 785. And that gives us another number. I did it again, not minus. That was the part right there. I kept saying minus because I was tracking it down this way, and that took me almost an hour to figure it out. This is multiply. And we got 15,386,000 and some zeros. Right? But we're not done yet. And if you figured out why we're not done yet, it has to do with this bad boy by the square root. So we now have to square root that number. R now equals, all right, we got negative 2,500, right? we need to square root this number. That gives us 3,922.5, and that yields negative 0.637. Let's try to pan this down a little bit. I apologize for my high-speed camera. Try to back out a little bit, maybe get some more space in there. All right, so that's where we're at. This is what our R value is now. I hope that helps. You know, basically, it's a little time consuming, but it's easier if you practice a little bit. Come up with your own different variations. You know, I tried doing one with bench press. That didn't work out too well. So have something that's a better relationship. Like, I don't know. I'm sure you can figure something out. Take your time, break it down. Have a system in play. You got to be really pragmatic when it comes to finding R, especially if you're not that practiced in it. So if you need to rewatch this portion, I'm going to move on to the R squared portion next, so we can coefficient determination move forward in the math process. All right, so we're going to hit coefficient determination real quick. So just basically to go over what that really means. It's the value that represents the proportion of shared variance between two measures in question. So in the previous example, right, we had the two measures were body weight, which was the dependent, or the independent variable, versus the pull-ups, which were the dependent variable. Pull-ups were dependent upon body weight in the previous example. So we got our ppm value of negative 0.637, which I failed to mention fell within that -1 to +1 range. So mathematically speaking, how do we figure out the coefficient determination? So we just basically square the result here. So take a second, pause the video, figure out what R squared is, and then we'll move on from there. So R squared, let me just erase this. R squared was 0.406. Notice every time you square a negative number, it becomes a positive number. So you'll always have a positive number when you have a coefficient determination. So let's talk about what that truly means. So we're looking at 40%, because you always want to multiply this by 100 to equal your percent, right? So you have 40.6%, and that allows us to see how strong this relationship is. So what we're looking at here is your true variance. So down here, if you remember from the previous series of videos, your variance, this was supposed to be true, this was your error variance. So now we're looking at 40% of the people here. Yeah, that was a pretty good correlation between body weight and pull-ups. So there was an effect against it. What we want to know is the error variance. So what we do is we'll go back to, because we're working with percents, we'll go back to 100 minus 40.6 equals 59.4%. And this comes up here. I know it's getting a little weird, so let me change colors. Right, so now we got literally more than half of the people who fall in the error variance, probably be like your big bodies that were able to do 12 or more pull-ups. You know, those outliers really screw up your variance or your true variance values. So this is how we get there. Understand it, practice it, do it a couple times. Watch this part of the video, leave a comment, send me an email. I don't know. Let's get through this. As we move forward into the chapter, we get to the straight line formula. That's what that little F means, formula, so function. What we get to is the y hat, this little emblem here above the y is called the y hat equals bx plus c, and we can think of it in terms of mx plus b, but that's kind of not representative of the material that we're covering. The other, well, we'll talk about it in a second, never mind. So how do we get to y? So we need to know what b is, we need to know what the x variable is, and we need to know what the c variable is. So x, when we get to the x part, when we get these other numbers, x is going to come from that modified chart again. It's that table 4.1. I got that modified table there. So reference that whenever you get to it. That will be that x, okay? And I'll show you what that is coming in Excel when I can demonstrate what the slopes look like. So here we go, all right? We need to figure out b first, right? We're going to start from left to right. B, if you really pay attention to b here, it should look extremely familiar to what we just covered. So it's literally a fraction of what the ppm formula is. So let's look at where I'm getting these values from. So again, out of that table 4.1, here's your n, you got your sum of x, y, you got your sum of x, sum of y, and then this number is literally a straight repeat. Over here you got your x squared variable straight off the chart, right? Like I said in the other video, plug and play. And then we got x squared, the sum of x's squared, right? This is the sum of x, sum of squared x, sum of x squared. However you want to say that, helps you remember it. Just remember that's how this plays out. So the biggest reason why it's like that is because we're looking for y, right? You know, we're y hat, right? Again, y does not equal y hat. They're relative of each other and kind of the same, but not really. So if we just remember what numbers we got the last time, this should be 19,600. Put that at a 0 here. And so what do? We divide these two numbers, and that gives us 0, put a 0 there, 1, 2, 8. And here's your b. Right? So now we figured out b. Now let's look at c. C took me almost 3 days to kind of figure out. In the textbook, it registers it as y bar minus bx bar. That's what that means. That's a bar. It's meant to be a bar above the letter. Now what that truly means is not that's mean of y, mean of x. And that's the reason why I have in my, like I said in the video, we want to have this total, but don't pay attention to the mean earlier. Now we're paying attention to the mean. So we have our mean of y, which is 6.5 minus the negative 0.128 times the mean of x, which is 152, and that, my friends, equals 25.888. It's not aligned because there's more decimals behind there, but that's how we get the c. And so we've moved back over to y equals bx plus c, right? Let me change colors. So our y hat, now we have our b value of negative 0.128 times any x value. So let me see here, what's a good one? 130. 130. I'm going to put a parenthesis on that so I can keep that straight. Plus 25 9.888, and now I need to grab a calculator because that was the end of my notes. Give me 1 second. Boom. 0.128 minus, I'm going to rotate my phone because it just helps me that way, times 130, which was one of the weight in the X category. We'll close that parenthetical, plus 25.888. Whoops. 0.888. And as you can see, we get a Y variable. Let's see, zoom in some, 9.248. So equals 9.248. Now that's all fine and dandy and everything, but let's look at something here. Right? So now we could take this y hat, and now we can find out what the error is. And we do this with every stinking y. And you can do this with every stinking x. I just gave you one. Alright, so the 130 had a y of 8. Which then again we minus that 9.248. Minus 9.428. Hit the wrong button. And we got your negative 1.248, and that's your error. This is the error. SE, SEE, SEP. That's all that business. And you could do, like I said, you could do that with every Y value. Hey everybody, I made a wonky mistake going to the next part of this video. I basically show you how to do this with Excel, but I forgot to turn the microphone on, so you're pretty much going to go at it deaf, if you will. I'll probably put some music to it, whatever, but take some time, go through it, see what I'm doing step by step. I make a few errors in there, and I show you how I correct those errors. Hopefully you can get it. If not, I'll try to redirect. Just leave a comment at the end of the video, and basically I'll try to revamp this. So hope you enjoy it. Again, take your time, review it. If you know how to use Excel that well, feel free to go through it. But you know, like I said, I make my mistakes and I correct my mistakes, and I show you what information I'm looking for. So I switch between both sheets, and you can see the information that's already been done, and then the second sheet is the information that I'm building out. So again, if you know what you're doing, don't take the time to watch. It's another 15 minutes, so enjoy it if you need to, but I'm sorry, I didn't really, I forgot to turn the microphone back on.